So now that we have our Cartesian, going to polar and trig is just a matter of you graphing this. So the very first thing I want to do is I'm just going to graph this. Okay, so I'll graph in purple. Why not? Okay, so here I am graphing. Where does this go? Where is negative 2 root 2? Where does negative 2 root 2 show up? So remember that this is your real axis and this is your imaginary axis. According to negative 2 root 2, I don't have an imaginary part. So where do I go for negative 2 root 2? It says it's about negative 2.8. So I need you to imagine that a plus bi is like your x comma y. Yeah, it's on the negative side of the axis. How far? I don't know, right here. We're just going to pretend. Good. So this point is negative 2 root 2, and then like invisible plus 0i. So if you need a reminder for yourself of how to graph this, it might be helpful for you to say plus 0, oops, not O, 0i. You can't see it, but like, and maybe I type that here, plus 0i. So that way it tells you I don't go up or down, I'm just there. So does that help you? Does that help you a little bit? Okay, good. So now I have to figure out the radius of that circle and the angle of that circle. So, or of that point. Okay. So I like to draw this circle so that you guys can all see. So I'm going to pretend that this, probably like this. And then let me scooch it over. So this circle has to be centered at 0. That looks pretty good. So here's my circle. What's his radius? That's your R. And then this angle here, remember you start as a closed book. You started as a closed book here. This is, remember, this is 0. And then you open the book all up to here. Okay. So what's my radius of this circle? Do you see the circle? Yeah. I'm just positive. It's always going to be positive. Very good. Someone gave me my radius. Someone else gave me my angle. So does the radius make sense? So my radius is 2 square root 2. Now, Ms. Johnson, why is it not negative? So because a radius is a length, it will always be positive. So you don't ever say, hey, can you run negative 20 yards to the donut shop and get us donuts? You don't say negative 20 yards, right? So my radius is 2 root 2. Does everybody see that? Everybody sees this is 2 root 2. Does everybody see that? I got 1 yes. I got 2. I got 3, 4. I'm looking for a specific name, just being honest with you. Okay, so we're all good. I got like all of you. 1, 2, 3, 4. Yeah, okay. So great. So that's my radius. Okay, now figure out my angle. What angle is this? What angle is this? What angle is this? Yes, it's 180, also known as pi. Okay, so I'm gonna use pi because I'm trying to get you guys more comfortable with seeing pi. If you write 180, can you also write pi? I need you to start moving in that area because honestly, I don't know what class you're gonna take next year, and if I prepare you for like the hardest class, then that means you're prepared for whatever class you take next. Okay, so 2 root 2 comma pi is my answer. So everybody okay with that? Does everybody see this as this is a circle of radius 2 root 2, and then this is the angle? Does everybody see that? Oh my gosh, stop it. Okay, now you guys, I know you know how to go from here to here, so go ahead and go from here to here. Okay. All right, and then once you're done, copy and paste your answer in here in the chat so I know that you're done. And so because it's r cosine theta plus I sine theta, I'm actually going to write r cosine theta plus I sine theta. Okay, and then close my parentheses. And then you're just going to tell me, but so what's my radius again? Yeah, it's 2 square root 2. So you just want me to write 2 square root 2, Miss Johnson? Yeah. And then instead of writing theta, what do you want me to write? Oh, you want me to write pi? Okay. In Desmos, if you want to write pi, you just spell pi. P-I. Pi is spelled P-I, not P-I-E. P-I-E is the food. P-I is your Greek letter. There it is. That's it. Got it? Okay. So I think once you're here at polar, you're fine to go to trig. It's getting from Cartesian to polar. So give me some directions to jot down. How did you go from Cartesian to polar? Give me some directions. What did you do? Yeah, first, number 1, graph the point. Now, this is funny because it says a plus bi, but in your mind, you're just graphing x comma y. I know that's weird. And you're like, Ms. Johnson, why didn't they just call it XY? There's actually a lot of reasons why you shouldn't call it XY, because then it just opens up like the floodgates for confusion. And we don't like confusion. In math, we like it to be very precise. So the reason why, even though we graph it like it's X comma Y, we don't graph it on that plane because that plane is technically your real plane. This is actually the imaginary or complex plane. Does that make sense? So think about it as, if you want to think about it as parallel planes, and you use your skills from graphing x comma y to graph this. So number 1, graph the point. Number 2, then what did you do? Okay, yes, when you graphed it, you found the radius. Now, this radius was easy to find because he was on the axis. Now, imagine if he's up here, you're going to have to draw that right triangle and figure out your angles there, okay? So find the radius, and then 3 is find the angle. We're going to add to these directions as we go to these other 2, okay? So let me pause this here.